Going to solve this third order trinomial. So we're going to find out when this polynomial here, sorry, not trinomial, this polynomial. We're going to find out when this polynomial here is equal to 0. To do so, I'm going to find a factor of this, divide it out, turn it into a quadratic. So I want a factor of the form x minus b, or a factor of the form ax minus b. I can then divide that factor out of here, turn it into a line, that's one of these, and a quadratic. So we have to guess at this point, but we have a bit of guidance for our guess. If I'm looking for a factor that looks like this, b must also be a factor of 6. If I'm looking for a factor that looks like that, b must be a factor of 6, and a must be a factor of 4, all at the same time. I will know that b is a factor of 6, I will know that x minus b is a factor of this polynomial if when I put b into the place of x in the polynomial, the whole thing turns to 0. I will know ax minus b is a factor of the polynomial if when I put b over a into the polynomial, it turns to 0. That would mean there's a remainder of 0 when that's divided out. So let's first look for a value for b that's going to work. My candidates are the factors of 6. Factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. I'm not going to do any of the positive numbers because you can see every term here is positive. So if I put in positive numbers, it's going to come out to a positive number greater than or equal to 6. It's never going to give me 0. So we need a negative. I'm going to try negative 1. Our polynomial at negative 1 is negative 4 plus 15 minus 17 plus 6. And luckily that worked. It's 0. So that means negative 1 is one of the roots of this polynomial. And if negative 1 is one of the roots, x plus 1 is a factor. X plus 1 is a factor because if x is negative 1, that factor becomes equal to 0, which will make the whole polynomial drop to 0. So I'm going to divide x plus 1 out of this polynomial here. So I'm going to divide x plus 1 out of 4x cubed plus 15x squared plus 17x plus 6. Okay, I need to multiply x by 4x squared to get 4x cubed. And then we'll subtract that away. This term here is gone. I've now got 15 minus 4. That's 11x squared plus 17x plus 6. I now need a term here that when I multiply it by x, it gives me 11x squared. So that's going to be 11x. So when I subtract these, I'm going to get 6x plus 6. And then this will be a plus 6. And when I subtract these, I get 0. Getting 0 here lets me know that there's no remainder when this dividend is divided by this divisor. Sorry, this dividend is divided by this divisor. It gives us that quotient with no remainder at all. So what that means is the entire polynomial can be factored into x plus 1 times 4x squared plus 11x plus 6. So all of that is equal to 0. So this third order polynomial is equal to x plus 1 times 4x squared plus 11x plus 6. And when I multiply them together, that gives me 0, which means either x is negative 1 or x is one of the roots of this quadratic here. We can repeat the process of guessing another root and then dividing out the factor, but you've learned other ways of dealing with quadratics that are a little bit quicker. So let's just factor this quadratic. So we've got 4x squared plus 11x plus 6. And I need a couple of numbers that multiply to give me 4. I'll try 2 and 2. I need a couple of numbers that multiply to give me 6. I'm going to try 3 and 2. And I'm going to multiply them across. 2 times 3 is 6. 2 times 2 is 4. And when I add them together, I get 10, not 11. So this doesn't work. I'm going to try it again. And this time I'll make this equal to 4 and make that equal to 1. 4 times 3 is 12, plus 1 times 2 is 2. They add up to 14, not 11. That doesn't work, but I can try it this way. 1 times 3 is 3, 4 times 2 is 8, and they add up to 11. So this process has told me that when I factor out this, I need 4x, and 4x must be multiplied by 2. So I'm going to put the 2 over here, because multiplication happens between the brackets, not inside of them. And my 1x, this is my 1x, it's got to be multiplied by 3. So I'm going to put that 3 up here. So what that means is our third order polynomial is now factored to x plus 1 times 4x plus 3 times x plus 2, and all of that is equal to 0. Or x plus 1 equals 0, 4x plus 3 is equal to 0, or x plus 2 is equal to 0. I like doing this when one equation splits into several. So x is negative 1, or 4x is negative 3, making x negative 3 over 4, or x is negative 2. So the three solutions to this are x is negative 1, x is negative 3 over 4, or x is negative 2. You could verify that by plugging any of these values in for x, and you'll see the whole thing turn into 0. Notice our roots, negative 1, negative 2, are factors of 6, and also 3 is a factor of 6, and 4 is a factor of 4. So like I said at the beginning, if we have a factor that looks like this, that is going to be a factor of 6. If we have a factor that looks like that, A is going to be a factor of 4, and B is a factor of 6, like this one here. 4 is a factor of 4, and 3 is a factor of 6. I'm going to show you a shortcut, a nice quick way of doing this long division called synthetic division. So let's say I want to do this